Hey, what's up, guys? Chung here. And yeah, it's been a long week, long day for me today. Yeah, so tired. I had a long meeting this afternoon for like 5 hours meeting, or not five, or 4.5 hours meeting. So okay. Anyway, so tonight let's take a look at this uh LeetCode problem, number 221, maximal square. Okay, so you're given a matrix, right? A 2D binary matrix, which consists of 0 or 1. And you need to find the largest square containing only ones and return its area, right? See here, so you should only return the area for this large for the square. What does this square means, right? Square means the left side and sorry, square means it's the same, right? Same length and the same width, right? And for example, this one, the square is still the same, still this one, right? Still the same, right? So basically that's why this square, the maximum area of this matrix is 4, because it's 2 by 2, right? Equals to 4. So every time we see this kind of like 2D like matrix problem, I think the first thing we should think about, we should consider is the dynamic programming, right? So for dynamic programming, I think what we need to think of is the what's the base case and how can we derive, right? How can we derive the dpi j, right, from the uh previous like dp value, right? So let's take a look, right? How can we think about this, solve this problem, right? I think it's kind of obvious. If the current I in J is zero, right? If the current ij is zero, then we know this one will be zero, right? Because if it's zero, there's no way. Because if the current one is zero, then from with the current one as the ending point, right? From here to here, right? That will be zero. Basically, I and j means from the 0, 0 to the current coordinates for in this big area, right? What is the what's the biggest square we have, right? So in this case, it's going to be 0, right? And what if this I and j equals to 1, right? What if this matrix I equals to 1? How can we derive that, right? So let's take a look at this example here. Let's say there's a 1, 0, 1, 0, 0. Yeah, I'll just use this example here. 1, 1, 1, right? 1, 1, 1, 1, 1, 1, 0, 0, 1, 0, right? So let's say, for example, for this one, right? With current I and j, if this current element is 1, how can we derive this value, the maximum square from the previous one, right? We can see that, the previous one is this is the that's the I and j minus 1, right? And this is sorry, that's the I and j. Yeah, that's the I minus 1 j. And this is the I j minus 1. And this is the I minus 1 j minus 1, right? So basically, uh, in order to get one more, basically in order to get uh, a bigger a bigger square, right? This one has to be 1. This one also needs to be 1. And this one also needs to be 1, right? Because in this case, let's say because this one, the I minus 1, j minus 1 is not uh it's 0, right? Basically, the value of this is 0. Even though this one is 1 and this one is also 1, but when it comes to this one, to this like I and j, the previous one we only we consider is to 0, right? Then this one will still be 1. Uh, let's consider uh let's consider this one, right? If we want to calculate this one. So the left one, right? So that's the I and j minus 1, right? So the I and j minus 1 is 2, right? So we store the length or the length of or the height, right? Since it's a square, it doesn't really matter. We just score the length of the square in this dp. So in this case, the dp j and I, this is the I and j minus 1, right? That's the one. What's the value for this? That's 2, right? That's 2 because from here we can get a 2, right? How about this? That this is the I minus 1 j, right? What's the square of this one? It's 1. Only itself, right? How about this one here? I minus 1 and j minus 1. It's also 1, right? It's also 1. Then we can conclude here for the current dp, right? So then what's the dp here? I, j, right? We need to get the minimum from all these three, basically, right? Because either one has a smaller numbers, has a smaller number, then the total will be based on that smallest number around among all these possibilities, pre previously possible values, right? So here we need to do a minimum of like I, j minus 1, right? And I minus 1, j, and I minus 1, and j minus 1, right? And then in the end, we plus 1 because the current one is 1. So we just get the previous result, and then we plus 1 will be the current one, right? Because the either one, as long as there's 1 on any of these three values, if anyone has a smaller numbers, we need to use a smaller number to be the smallest, to be the previous result. Uh, I don't know if I explained it clear or not. I think maybe I can give a few more examples, but that's how this like dynamic program formula uh, was constructed here. And maybe I can give a few example here. Let's see. All right, let's do this. Yeah. Uh, let's try this, right? let's try yeah, let's try this number. Let's try this one here. Okay, right. So what's this one? What's the I minus one? This is the ij, right? This is the I minus one and j, right? What's the value for this? 2, right? How about this one? That's the I j minus 1, right? It's also 2, right? Because this is 2, this is 2, right? If we're only considering this, the I minus 1 j and I and j minus 1, then our value is going to be 2 plus 1 is going to be 3, right? But is that true? No, right? If we check this one, so the actual square for this like I and j is still 2, right? Why? Because we have this limitation here, right? That's the I minus 1 and j minus 1, right? So what's the value for this I minus 1, j minus 1? It's 1, right? Because this one is 0. So the dp so the dp for this position is 1, right? So we have 2, 1, and 2. And we among all the three possibilities, we need to get a minimum one and then plus 1, right? Yeah, so that's basically the the analysis. And so let's try to code this thing, right? So, and we're gonna have like the length and width of the matrix here so that we can initialize our matrix array. Uh, n equals to length uh, n, right? So we're gonna initialize a 2D like DP array here, and the default value will be 0 because we just initialized 0 for any of the values, the DP element first at the beginning, right? And we're gonna do n plus 1 and n plus 1. I'll explain later on why we need to do a plus 1 here. 4, right? In range n plus 1, right? And then I think we can do a sanity check here. So basically, if not matrix, right? If not matrix, we do what? We just return 0, right? And so here we're gonna do a 4, right? And then we do a for loop here for I in range. So here we start from 1, from 1 to m plus 1. And then here for j in range, right? And then basically what do we do? So if, right? If this ij, right? Matrix I minus 1, j minus 1, j minus 1 equals to, I'll finish writing this one and then I'll explain this later on. Do a dp, right? Like I said, j equals to minimum, right? dp I minus 1, j dp I j minus 1, then dp I minus 1 and j minus 1, right? And then in the end we just plus it, plus 1. And in the end we just return the dp m and n, right? So that's it for this problem. Okay, let me go through this one here. So first why we need to do a n plus 1 and m plus 1, right? You can think it in two ways. First way is the since when we calculate each dp, since we're calculating each dp, we start from 1 here, right? And since we're going to use like I minus 1 and j minus 1, if we don't, if we're not like initialize it to n minus 1, m minus 1. Let's say if we start from 0, in that case, if this is n and m, right, then we need to start this one, we need to start from 0 to m, right? In that case, 0 minus 1 will be minus 1, right, which will be out of index, right? So in that case, since every time, even for the first element, we still will use this formula in order to make this like index not smaller than 0. That's why we need to start from 1, right? And another way of thinking about the initialization here is because the dpi and j, right? So dpi means uh, with one with column 1 and column 1 and row 1, right? You can also think it in that way. Which this means the column 1 and the row 1. Then in that case, for that we need to like start from 1 to m, right? 1, 2, 3, 4, 5, and 1, 2, 3, 4. So, and here that, and since we're doing this n plus 1, m plus 1, right? And since we're using this like a one base like index, right? Since this 1 means the first element, right? But the matrix itself is 0 based. It's not 1 based. That's why when we trying to get the actual element in the matrix, we need to use I minus 1, j minus 1, right? Yeah. So basically, if this is not is zero, if it's 1, then we will try to get the previous minimum result and then plus 1. If it's 0, we simply does nothing because we initialize uh, each element in the DP array to 0. So if 0, we basically we do nothing. In the end, we just return this one here. Oh, sorry. Oh, sorry. Yeah. Oh my God, I'm so tired. So we are not, since here we're only storing the what the maximum length of the square, right? And of the current length. So this one could be 0, right? For example, this one here, this will be 0. So we cannot simply return this one. So we have to we have to maintain a result here. To maintain a result, and in the end we return a result here. So how do we do this? So every time we have a 1 here, right? We do a answer, right? We updating this answer here. Answer dot dpij, right? Mm, square, right? That's how we do the square. So with the current dp, with the current maximum square length, let's try to calculate the area and compare with the existing one. And then in the end, we just return this one, right? Every time we always get the bigger one. Oh, yeah, sorry. Yeah, I think, yeah, my mind is not functioning now. So answer, yeah, sorry. Here, define answer here. Yeah, cool. So yeah, so yeah, that's pretty much it is. So the key point here is we have to get the previous one from up, left, and diagonal. We need to get the minimum value from all the three, right? And then only all those threes are valid, then we can have like we can increase the next value, the next DP by 1. Otherwise, any one of this has a smaller values. The basically the new DP will be it's bound to all to the minimum of all the three values. Yeah, and then Along the way, we just keep updating this answer, right, with the current area, and in the end, we just return it. Cool, guys. I think that's it for this problem. Sorry about this bad explanations. Yeah, kind of tired today. Yeah, I'll be seeing you guys soon. Yeah, hopefully tomorrow. Yeah, see you guys. Bye.